Today we're going to talk about our final type of geometry proof in this particular chapter, which is angle proofs. So we've already done properties of equality with algebra proofs. We've used properties of congruence in our segment proofs, and all of these properties can be used with angles. And then we're going to add in some more definitions and postulates that we use. So we don't have to write anything in today, we're just going to read these through. So definition of congruence: if the measures of two angles are equal, then they're congruent, and vice versa. So think of it as like if and only if. Angle bisector: the definition: an angle bisector divides an angle into two equal parts. The definition of complementary angles, which is if they're complementary, their sum is 90 degrees, and if their sum is 90, they're complementary. Definition of supplementary angles: again, supplementary angles would add up to 180 degrees and vice versa. Perpendicular lines form right angles, so if you have perpendicular lines, you know you'll have four 90-degree angles. And then definition of a right angle is a right angle equals 90 degrees. So those are all definitions that we can use in angle proofs. There's also a postulate that we use. So postulate is just an accepted fact. So angle addition, like segment addition, but this time we're just adding two smaller angles to make the third angle. So the whole angle is ABC. And then we have theorems, and these are things in geometry that started out as a theory and they've been proven to be true. So the vertical angles theorem is if two angles are vertical, then they're congruent. The complement theorem is if two angles form a right angle. So if you have a right angle and it's made up of two other angles, then they are complementary. The supplement theorem is that if you have a linear pair, so if we remember we have a line and then we use a ray to create a pair of adjacent angles, so linear pair, automatically supplementary. And then congruent complements theorem means if one angle is complementary to two other angles and is also complementary to B, then angle A is going to be congruent to angle C. And then congruent supplements theorem: if angle A is supplementary to B and angle C is supplementary to B, then A must be congruent to C. It's a little bit like transitive property for angles. So what we're going to do is, using this page, we're going to look at our second page and figure out which definition, theorem, or postulate allows us to say what we're saying here. So, statement number one: if angle A is a right angle, then the measure of angle A is 90 degrees. And that is the definition of a right angle. Number two: if angle X is supplementary to angle Y, and angle X is also supplementary to angle Z, then angle X is congruent to angle Z. So we have an angle that's supplementary to two other angles. So according to the congruent supplements theorem, then angle X is congruent to angle Z. Okay, to abbreviate. If we have this diagram, angle 1 and angle 2, judging from the diagram, we know these are vertical angles. So if two angles are vertical, then they're congruent. So that is vertical angles theorem. Number four: if the measure of angle P plus the measure of angle Q equals 90, then we can conclude that angle P and angle Q are complementary. And that is the definition of complementary angles. A little bit different to number four is number five: if angle M and angle N form a right angle, then angle M and angle N are complementary. And that is the complement theorem. Number six, we have this picture, angle 1 right here, line M and line L. If line L is perpendicular to line M, then we know that angle 1 is a right angle. And that is definition of perpendicular. Feel free to use the symbol for perpendicular instead of the word if you like. Number 7, if angle W and angle X are supplementary, then the measure of angle W plus the measure of angle X equals 180. That's the definition of supplementary angles. Number 8, if angle L is complementary to angle M and angle N is complementary to angle M, then angle L is congruent to N. So angle L is complementary to two other angles, therefore those are congruent to each other. So that is the congruent complements theorem. Number 9, if angle A and angle B form a linear pair, then angle A and angle B are supplementary. That's the supplement theorem. If angle N and angle P are complementary, then their sum equals 90 degrees. So that's basically just the converse of number 4. So this is the definition of complementary angles. And number 11, given this diagram, we have two smaller angles, JKM and MKL, that we can add together to get the largest angle, JKL. So just like segment addition, we are adding angles together to get a larger angle. So this is angle addition. And finally, if the measure of angle R equals the measure of angle S, then angle R is congruent to angle T. So again, we went from equals to congruent, so that is the definition of congruence. So those are more specific sheet that we just looked at. So to finish up, you have a half sheet that has the reasons already given to you for each of the 6 proofs that you have. So we're just going to do number 1 as an example. So we're starting out with angle PQR is a right angle. So we can put in the right angle symbol in the corner. So again, always knowing that what we start out with is what's given. So if angle PQR is a right angle, by definition we know that the measure of angle PQR equals 90 degrees. So that's definition of a right angle. So again, keeping in mind in a proof, you're always looking to how can I get from this statement to the next. And when you know that, that's your justification. So now we're just looking back to the diagram, because somehow we have to get in to the proof the names of these two angles. Well, right now in steps 1 and 2, those names are not there. So we look to the diagram and think, what else can I do with what's in this picture? So I can always add the two smaller angles to get the larger angle. So I'm going to introduce the names of these two angles by showing angle addition. And then I know that angle PQR equals 90 degrees. So instead of putting the measure of angle PQR here in letters, I can put the degrees that it equals. So since I'm replacing PQR and 90, this is substitution. And then finally, since the sum is 90, I know that these two angles are complementary by definition of complementary angles. So good luck with the next proofs. Make sure that you use the half sheet to help you and cross out the reasons as you use them.